Hello everyone. So this is a question from JEE Mains 2026, 8th April, Shift 2. Given below are two statements. So they have given us two statements. The first one is in 30% weight by weight solution of methanol in carbon tetrachloride, mole fraction of carbon tetrachloride is equal to 0.33. And the second statement is mixture of methanol and carbon tetrachloride shows positive deviation from Raoult's law. So we have to choose which one is true, which one is false, and the chapters involved is solutions. Okay, so I will mark the few important points in statement 1 that we have been given 30% mass by mass solution of methanol in CCl4, and we are supposed to calculate the mole fraction of CCl4. Okay, cool. So when they say 30% of weight by weight or mass by mass solution of methanol, that is CH3OH in carbon tetrachloride in CCl4, the meaning is that we have, since it is percentage, we can say that 30 gram of methanol, that is CH3OH, is present in 100 gram of the solution. That is the meaning. So what will be the mass of carbon tetrachloride? So it will be 70 gram. So 70 gram of CCl4. So what is the composition of the solution? 30 gram CH3OH and 70 gram carbon tetrachloride. Cool. And we also know that when we have two components, A and B, in a solution, so the mole fraction of A is equal to number of moles of A divided by number of moles of A plus number of moles of B. Similarly, mole fraction of B will be number of moles of B divided by number of moles of A plus number of moles of B. So basically the formula is mole fraction of a component is number of moles of the component divided by total number of moles of the component. Cool. So here we are supposed to calculate the mole fraction of CCl4. So that will be equal to number of moles of CCl4 divided by number of moles of CCl4 plus number of moles of the other component, methanol, CH3OH. Cool. To calculate number of moles of CCl4, we know that given mass of CCl4 is 70 gram. We know that. We have to calculate the molar mass of CCl4. So molar mass of CCl4 will be 12 plus 35.5 into 4. So that comes out to be 154. Okay, to calculate the number of moles of CH3OH, methanol, so we need to know the given mass of methanol. So that is given to us as 30 gram, and the molar mass of methanol will be it will be 12 plus 3 plus 16 plus 1, which is 32. Okay, cool. So we have all the information, so we can substitute these values in this particular equation. So on substituting, we will get mole fraction of CCl4 is equal to 70 by 154 divided by 70 by 154 plus we will get 30 by 32. So when we do this calculation, we will be getting that the mole fraction of CCl4 is approximately 0.3265, which can be rounded off to 0.33. And what is the first statement saying? The first statement is saying that the mole fraction is equal to 0.33. Yes, so the statement 1 is correct. Okay, statement 1 is true. Okay, and the statement 2 is saying that mixture of methanol and CCl4 shows positive deviation from Raoult's law. Okay, to understand this, first we should know what is Raoult's law. So Raoult's law is Pi is equal to Pi naught into Xi. Okay, where Pi is partial pressure of component I. Pi naught is partial pressure of component I in the pure state. When we have taken only Pi, then what is the vapor pressure? So Pi naught is partial pressure of component I in pure state, and xi is the mole fraction of I in solution, in the solution phase. Mole fraction of component I in solution. Okay, these are some important points. Now we have something known as ideal solution. So what is an ideal solution? Solution in which, let's say we have two components A and B. So solution in which each component obeys Raoult's law under all conditions of temperature and concentration is known as ideal solution. So what is the ideal solution? Solution in which each component obeys Raoult's law under all conditions of temperature and concentration. Okay, so macroscopically there are two conditions when two components form a ideal solution, that is delta V mixing is equal to 0 and also delta H mixing is equal to 0. These are the macroscopic conditions. And the microscopic condition is that the AB intermolecular interactions are of the same magnitude as AA or BB intermolecular interactions. Okay, so microscopically AB molecular interactions will be similar to AA or BB intermolecular interactions. So this is what happens microscopically. Okay, that is, the new interactions that is set up between solute and solvent is similar to the old interactions which were already pre-existing between the solute or the solvent molecules. And the graph looks like this between vapor pressure and the mole fraction. So let us say I'm taking the mole fraction of XB from 0 to 1, and so the graph will look like this, assuming that P naught B is greater than P naught A. So this is how the graph looks like, and these are the individual graphs. Okay, this is for ideal solution. Now coming to non-ideal solutions, solutions which doesn't obey Raoult's law, okay, under all conditions of temperature and concentration. So non-ideal solutions which don't obey Raoult's law, and for them obviously the macroscopic conditions are delta V mix, that won't be equal to 0, delta H mix, that also won't be equal to 0. Okay, so there are two types of non-ideal solution. First one is non-ideal solution showing positive deviation. Non-ideal solution showing positive deviation. Okay, so there are two types of them. The first type is non-ideal solution showing positive deviation. For positive deviation, the graph turns out to be something like this. So instead of having these straight lines, this is the curve for the total vapor pressure. This is the curve for the individual vapor pressures. So you can see this is the curve for total vapor pressure, this is the curve for individual vapor pressure. So we can say that total vapor pressure for any solution, any composition of the solution is greater than corresponding to an ideal solution of same composition. For example, let's say this is the composition. For ideal solution, this is supposed to be the total pressure, but for a solution showing vapor pressure, this is the total pressure. So it is more than what is expected in the ideal case, right? This is expected from the ideal case, but this is actually the vapor pressure of a solution showing positive deviation. So we should write this statement, important, that total vapor pressure greater than corresponding to an ideal solution of same composition. Okay, so this is happening because the AB intermolecular interactions are lower than AA or BB molecular interactions. Okay, the reason for this behavior is AB molecular interactions are, the strength of them is lower than AA or BB molecular interactions. Okay, due to which, since you can see the new bonds between solute and solvent are weaker compared to the old bonds that were existing between the solute and the solvent. So now the new bonds are weaker, and hence they can the new bonds are weaker, hence they can break this bond easily and fly away to form vapor very easily. That's why the vapor pressure is more, you can see, compared to what is expected in the ideal case. Okay, so a very important example is the case what is given to us, that is mixture of methanol and CCl4. Okay, so in pure, if you have pure methanol, very high fraction of molecules are hydrogen bonded because they're alcohols, and alcohols show intermolecular hydrogen bonding. So they exist something like this, in this way. So this is one molecule, this is another molecule. So you can see here partial negative charge, partial positive charge. So these are the hydrogen bonds. So we know, right, whenever hydrogen is bonded to a highly electronegative atom like oxygen, nitrogen or fluorine, then they show hydrogen bonding, right? So these are the hydrogen bonds, strong hydrogen bonds, which are already existing between methanol molecules. The moment we add CCl4, okay, so its molecules gets in between the molecules of methanol. So the CCl4 will come and sit in these locations, due to which it breaks the hydrogen bonds and decreases the methanol-methanol interaction, due to which, the new bonds between CCl4 and methanol are not very strong, and then they can easily form vapor. Okay, so what happens is, upon adding CCl4, molecules gets in between molecules of CH3OH and break the hydrogen bonds and decrease methanol-methanol interactions. So therefore, what will happen? Leading to a very high vapor pressure, contrary to what is expected, and hence they show positive deviation. They come and sit exactly in between these hydrogen bonds. So they are, it breaks down. So therefore, the total vapor pressure will increase and the solution will show positive deviation. So therefore, statement 2, that is mixture of methanol and CCl4 shows positive deviation, is true, and it is correct. So both these statements are correct. Statement 1 is also correct. Statement 2 is also correct. Okay, thank you.